So I know that it's known as a genetic disorder, relating so things like gene mutations, for example. But how does electricity fit in with all of that?
Well, electricity, or the body's electricity, or bioelectricity, is is a set of signals, a language the cells use, and unless you listen in properly with the right, earphones, you wouldn't hear it. So a lot of emphasis has been on the genetic basis. Remember, again, the 50s and 60s had this structure of DNA determined. So everything became molecular, including the disease. Now, and then you look at the genes and say, there's a mutation here. The gene is a little bit different in cancer, and that may or may not be inherited. And of course, some cancers are hereditary and so on. So this became quite a I don't want to say dogma. It became the emphasis in the field. Cancer is all to do with genes. In fact, everything is to do with genes. But in fact, cancer is not primarily a genetic disease. It is an epigenetic disease. And I'll explain that to you. I think this is something that everybody should know beyond our main topic today.
I should know this. I need to know this. What is an epigenetic disease?
We are born with 22,000 genes. Okay, this is much less than it was thought. The expectation was we had about 200,000 genes, 10 times more. But when the Human Genome Project was completed, it came up with many fewer genes than they expected, 22,000 genes. But these 22,000 were only 1 or 2% of the whole genome, of the whole genetic material that our cells, our bodies carry. So what does the other 99% do? We didn't know for a long time. And people called it junk DNA. Some people called it dark DNA because we didn't know. In fact, we now know that 99% actually manages the 1%. So those 22,000 genes are under constant modulation, up and down, expression somewhere and not. And the problem with cancer is that, for example, the gene that we discovered, the protein, this sodium channel protein that we discovered, turns up. It's a normal protein. It's a normal gene, but it turns up in the wrong place because there is no place for it in your breast or in your prostate or in your lung. But because of the pathological change, it is expressed and then disturbs what we call the homeostasis, the balance, the normal balanced functioning of that part of the body, and ultimately leading to cancer.
Sounds like a healthier society where you've got 99% controlling the 1%, rather than the world we're in where it feels like the other way around.
This is what the Times magazine called on its front page, we are no longer the destiny of our genes.
Right.
Okay, because we can change our genetic structure. So the epigenetics means we can change those primary genes, let's call them 22,000, and then live differently. And they respond, this phenomenon, this epigenetics, responds to diet, lifestyle, social well-being, like we're doing today, good social interaction.
Yeah.
Okay. And so we are not the destiny of our genes. You're not the destiny of what your parents gave you.